Yes. And just so people remember, nice little menu, and we can have X number of players. And that's what we're looking at today. And obviously, this is also just exemplifying that it works in builds, and you can exit and join. And yeah, let's see how it works in the game. Actually, let me go out there. So the main thing I obviously want to cover today is just the simplest approach to input and figuring out how to connect multiple controllers with multiple players and assign them correctly, so that when a new player joins and they pick up a controller, that controller gets mapped correctly, and when they, let's say the controller disconnects and or loses power, then it should also remap that when you give it power again. It should correctly re-enable the controller to the right player. And so I put on the GitHub this time. This is the only thing I put on the GitHub. This smallest section of code that you need in order for this to work. I'll go through it in a second. I'll also just mention that this was built based on the subject of last time that I was talking about ECS code and not the what were we doing last week? That was
we did the DOS Community Challenge.
Yeah, exactly. Yeah. So this is the episode 9 of creating a character controller.
Yeah.
And that's why the project looks very similar. But this time I moved and changed the characters a little, because then I get multiple skins. But more about that later.
Let's dig into character.
Let's dig into what this code is, because this is definitely the hardest part of making a Dutch game work. To anyone that has ever worked with the new input system before, you might know that it can be kind of it's very game object oriented by default. Mm-hmm. Like the default approach that is recommended is you create a game object, you put something on it called player input, and that becomes your game object, and then you have another game object. So this is your prefab that you're going to spawn, and then you have another thing called the player input manager, and this is the join behavior, and then you set up things with that. And I don't quite know how this one is meant to work. I don't like this in particular. I just want the simplest thing, especially for Dot, because creating game objects quickly gets very difficult to understand. But underlying what's it called, the player manager that we just saw, actually there is an API for it, and it was created based on this API. It's called input user, which is a static class so that you can just access as part of the input system. And you can ask it to listen for a specific amount of unpaired devices. And then there's also another thing called on unpaired device used, which obviously anytime you press a button on a device that have not been paired yet, this will get called. And it will, give the control, which tells you the button that you pressed on that unused device. And then once you've, done all this handling, then you say, hey, yeah, you should listen for one list. This essentially, in a way, indicates that you're listening. You successfully managed to create a pairing because you're listening for one list, right? Well, how do you then pair up a device so you don't keep calling this event? Well, this is what you need to do. Combine, actually, this call in particular. And we have a few if statements before this, because by default, all controls go in here. So if I start moving my mouse around, this event gets triggered by my mouse. If I start moving the analog stick, and I think even just moving my controller, because there's a gyroscope in some of those controllers. Yeah. Therefore, I'm making sure that I'm exiting out of any buttons, and I also don't want the mouse, because a mouse and a keyboard actually count as two separate devices. And what I'm doing down here is simply making sure that
I hear you now.
Okay, yeah, my cat just ripped out my cable. So, I just wanted to make sure. But so essentially, if we press something on the keyboard, remembering that no mouse events get caught, then we should also find the mouse, which we do here, and then we pair that with the same user. So the same user gets two devices in this case. And how do we create a user? Well, when we do input user.perform pairing with device, it automatically creates a user There's another function you can use if you don't want to pair a device when you create a new user, but this is the default one you can use. And so now you've paired a new user, and you probably want to make sure that you have like a controller set up that actually uses that. So if you new up a Kyle input, which if you remember last time, I had something, an input asset here, and you can say generate C# class. Like this is the input asset with some events on it.
Yep.
If I generate the C# class, then I get this little class, and this is what is generating in the Kyle input class, because I put in Kyle input here. Last time it was Kyle. I should probably have renamed this to player input or something. Jamo input. Hero input. I think hero is the most normal for the main characters. But yeah, so like any normal input system setup, you just new it up and enable it so that we start listening to events on this controller. But obviously, by default, when you just do this alone, it will listen. This player controller will listen for all events. So whether my PlayStation controller, or Xbox controller, etc., I press that, an event is called from this, and read value and so on. So I want to make sure that this is filtered to only match the controller. And I can do this through the user. So I can associate this specific controller with the user. And because the user is already associated with the device, that means that now this player controller only gets events when the matching device is used. So you sort of now have a setup where the user is in control of the devices, and there's a one-to-one mapping, which is awesome. And
again, that's just to basically make sure that each controller is only controlling the player they're associated with, right?
Exactly. And this also makes sure that if I disconnect my controller and connect it again, then it should be assigned to the same user.
It should map to the same user. Nice.
Exactly. And that's why you want to do it this way. Because if you just did the normal old input system way, then you won't necessarily know the indexing, because the indexing changes as a new controller maps in and out. The old input system, what often happens is I disconnect a controller, and let's say player 1 gets the controller disconnected, then now player 2 starts steering around player 1 because the index gets shifted.
Because they...
Yeah. So this just makes sure that we now have a nice little mapping. And because this is Kyle input is a reference type, we can store that on something else. And in the project, what we are storing here is we are simply creating an entity that stores that player controller. That means that we now have an entity with a player controller on it, and we can ask that player controller whether or not it's used. And this actually is the whole basis of how this project is set up in a way. And obviously, I'm gonna go into detail on how exactly I make that work, because there's a lot to this in the project. If you notice, just like looking at the scene alone, hopefully you guys can see this fairly okay.
Yeah, should be good.
But you can see 4 cameras here and the main camera. When I go into play mode, what actually gets moved around is just that camera and the 4 cameras here. And as soon as I hit start, I show one of those cameras. Interestingly,
Nice.
I also make sure that these are not shown by that camera.
Hidden from the other camera, yeah.
Yeah, or any game view camera. So these are always here, and they are obviously only rendering, but that's how that works. And then there's a render texture that you put on. You guys can dig into the code or ask after if you guys are interested in how that works. I then, wait on a certain amount of characters and then enter. Something interesting happens there. It will figure out how to set up the split screen, because by default, you will note that we have these objects here, the cam player 1, 2, 3, 4. And obviously, one of the main problems that arise from having cameras normally is, how do you get a camera that matches the player? Normally, it's already annoying to get the camera from ECS, and now you have to get 4 different based on a player. For my simple use case, I chose a singleton approach just because it is a specific number. It's not a dynamic number, really, and 4 is such a low count. So all I have on it right here is a component called, and this is the same one from last time I was explaining about this project. It's the same component, but now I extend it to which player it belongs to. And so if we go in here, on awake, simply make sure that it sets what it belongs to. And so now you can ask for all 4 and map them together. And we therefore can say, hey, this character has a player ID of 0, then okay, then you should use camera 0. And that continues. You guys can try and play around with this code to really get a feel for it. But the basic gist of it is, if we read here, then on awake also sets this active as false, which is why it doesn't display when you start up the game. But let's say it did. What would happen then? Well, I first need to change the priority a little so we can see all the cameras. But then you can see then we already have the split screen setup. So by default, the split screen setup looks like this. And so my process for assigning the correct split screen setup based on how many players joined the game is just a matter of obviously counting how many players joined. And then if it was only 2, then these 2 simply needs to have these values here changed. So this one needs to have this value halved, and this you can see in the code in a second. But you just change around which of these are shown and which are enabled, and it's fairly easy to do.
How do you handle 3 characters? How do you lay out the cameras for that?
Well, I base this on trying to be fair to everyone, so therefore I can't give extra real estate to the third player. So obviously then they can just get the whole bottom.
Right.
So I simply, and actually let me just show it because I can show it very easily. There you go. And then enter the game. No user to see here. Lol. And so that works because I only have 3 cameras enabled now. All of the 5 other cameras, the one spinning around and the 4 preview cameras, they are all disabled at this point. So only 3 cameras are rolling. This one is set to this viewport, this one is set to that view, etc. And then I have a UI displaying in front of this section. If I didn't have a UI displaying in front of this segment, then I would see whatever was in the camera buffer last there, because nothing is trying to render to that part of the screen.
It'd just be like the frozen image, you mean?
Yeah, exactly. It would be essentially the frozen image, and most likely because you had it in the input menu when you joined the game, then it would be off the input menu before it went in, right?
And actually, real quick, this is just kind of a relevant question. Would it be possible to center the bottom camera?
What do you mean by center the bottom camera?
Like, so you have like the 2 here, and then instead of the one here, you move it kind of over to the center.
Indeed. And obviously that is a very similar code as when I take this and stretch it out so it works on the entire top surface. You would just have to make sure that the third camera, and you have access to that, say the third camera actually should be assigned the values to map to this region. So that code path is very easy to add, and I'll show that in a second later. Then we don't really have that much more. This is the overview camera. These are the players, and they will get disabled by default. And then as soon as you enter play mode and you actually enter the game, then the X number of these will get re-enabled with the correct viewports. Then the only thing we have in the subscene right now is the environment itself, because again, this is a DOTS game, so we want all the physics and character controller and DOTS rival character controller, everything to be in DOTS, because it is a DOTS project. So the environment is there, and then we have something called the player manager, which simply says every time you spawn a player, these are the prefabs that I expect to spawn. So if we remember from last time, we had a third-person character, which is the character itself, and then we have the orbit camera, which is the camera that moves around the orbit. I need to have both of these because if I just put the orbit camera underneath this one, then it would also have the parent relationship of doing that, which I want the orbit camera to live outside. I want to be in the top level.
Right. That's a cool way to handle that.
So, okay, that's set up. Then UI Palace is just all of these weird ones. You can even see the view frustums of the cameras. Game object, that was what I just had earlier, so that has nothing to do with the project. This is the last big workhorse of the scene. And it basically just tells some managed info about the project. So not only does it obviously show the UI document, so this is the UI displaying in the game, which is why it looks like that. Also, I should make sure to control set all the changes that I did. There you go. Control set. Then UI document has the UI document itself, but it also has references to the render texture that maps to each of the UI Palace drawing cameras. That way I can, that way I have a way to get the reference to those render textures. I could just as well have put them on a game object in here that had a baker that baked these on using a Unity object ref. But in this case, it was just easier for me to put all the managed references here. Then I have the player input description, which is a small little UI, because if you enter play mode start here, note how we have all these spawning.
Yep.
This is dynamic, which is really cool.
Right.
So if I were to add another action in here, it will actually add that here as well. Now, I'm not going to do this now, but it uses the name here to figure out that name, and then it will see, okay, is this a left stick? Well, if it's a left stick, then it just needs to draw one texture here. Otherwise, if it's a WASD, for instance, because it's a composite of 4, then it will look up the texture for each of these and then build a composite texture for this.
Did you have to do a lot of that kind of manually, though?
Not really, no.
Like
I mean, I did have to make,
like it knows that like the W key maps to a certain asset or whatever.
No, that part I did have to do manually, and I guess I should also show that because that's a big part of this. If I go into the project is organized terribly right now. We have scripts in the root folder and so on. But if I go to the UI folder, not the UI toolkit folder, which both live in the root. This is brilliant. Then we see all the render textures. We see the style, but most importantly, we see these scriptable objects. So I used the scriptable objects here.
Cool.
So for the keyboard, I just say, if you are looking for I, then find the keyboard I texture, etc. And then I do that for every one of these. These map to the name in the input system. And I also have it logging every time that this is requesting a draw that you don't have a texture for in the lookup. So that way you can start adding if you're missing any names here. But this basically just does a mapping. And then you have like, if it's a PlayStation 5, then left stick should return this, and start should return this texture.
Nice.
And then obviously you just have to have what is essentially a dictionary that maps together. And that was actually the last segment here.
Right.
That maps the name of a controller to what layout to use.
Okay.
So there's a way for you to get the input description of the controller you have that will say stuff like if it's an X input, which says that it's an Xbox controller. Or if it's hit wireless, then you can see this is actually a Switch Pro. There's also a way to get the manufacturer, but that is in a way unreliable, and you don't need the information. Right now I've made it as generic as need be. Then if I later on wanted to add more of the input description in there, like the manufacturer and the actual product name, because you can add the product name, then I can put that in here, and then the dictionary would obviously grow. But it's a fairly simple setup because you could just map to the same scriptable object.
Exactly. Yeah.
And yeah, so what this is just a UI element for that segment. A way for me to, in the UI, search for the icon and replace that with what I need, and search for the action name and replace the text with what I need.
Cool.
Yeah, so let's dig into some code. Let's finally look at some code. Now, I guess UI hook is the most interesting bit. So I mentioned earlier that we have the UI hook, which is this thing here. This is the one that has all the managed references. You can see
And, if you
the
could
way
actually
that
just zoom in a couple clicks, please.
yes, of course.
Sweet.
Let's do this as well. Then what you can see here is we essentially have a dictionary lookup here. I would recommend normally to put it's because you can't serialize a dictionary in Unity. So I just have like an array of the combination. And the way to look it up is link right now, but I really would recommend someone cache a dictionary and then create that dictionary in the wake. I was just lazy here. Otherwise, the main purpose of this is you really should not call UI hook instance that often. I still want the system to later on go and be the actual owner of most of the UI handling. And the reason for that is simply it helps out with dependency management. The big problem here is that there's a difference between when a scene loads and when a subscene loads and when a system is run. So in order for me to figure out when these references are valid to use, I just create an entity in the default world. And again, I generally recommend against the default gamer injection world because it immediately stops you from being able to use any sort of netcode project. It doesn't immediately stop you, but often it can harm making a netcode project because then you don't know the differentiation between what should run in netcode and what should run on client.
Well, you actually can set the default game object injection world.
100%. The main issue here is simply my point here is simply that this will mean it's always gonna be often the client world is the default approach. There are some cases like if you have audio for each player, then that might cause issues. It's a little easier to look at the other way around.
Makes sense, yeah.
I did put everything inside one thing here because I did make this in a weekend for you guys to see. So sometimes it's nice to just have everything in the system. But we have the UI system, then we have the enter game mode menu system, and we have it's a long system, that one. And then we have the game start system.
Looks like it.
And the differentiation between that system is the UI system just sets up so we have some basic handling for the main menu and the UI. And then at some point you click the right buttons and then you are in the enter game menu. Once you're in the enter game menu, then you need to handle everything that has to do with remapping the controller, that code path we saw earlier on GitHub, and creating entities, etc. I'll go into detail about this later. And then at some point, you have made sure that everyone is ready and they press play and they're allowed to do so. Then game start system starts running because this entity here is created called isInGame. And so on start running starts and the main part of the game starts working. So that's the three systems. A quick glance at the overview. Now, I won't go into this too much. It basically just ensures that you press the start button in the main menu, and then it will not show that menu anymore. Instead, it will cast what is essentially an event. So right here, I'm using entities as events. So I'm spawning an enter game menu entity, calling out that, hey, you press this start button. So now you should start setting this up. So you did that. You press the start button, and this system starts working because this condition is met. And obviously the system also has to store some state. That's great. And it also has to get a reference to the UI system that we had earlier, because that one has all the references and it has already pre-cached everything. So now I'm already in the nice place where I can say, and I probably should actually have a require for update saying it's dependent on the UI system. But I can pretty much expect that you can't press the UI button unless that happens, so it's fine. So I have the UI system, and I can say, hey, I'm waiting for X number of players. I'm gonna display the intergame menu. So as soon as I enter have this event called, then it's this system that's responsible for making sure that that menu is displayed. And then I also start listening for events. So only when I am in that intergame menu, I'm starting to listen for events. And this is where we do what we saw earlier. Another thing that I also do here, which was not there the last time, is I do this little thing where I get the menu state that lives on this system, and the menu state stores the current state of our menu, which in this case is only these four, I guess 8 booleans. It indicates, hey, in our menu, how many slots are currently occupied. This is because when you, let's say, player 1 joins, then player 2 joins, and then 3, and then player 2 exits, then you still have 1 and 2 occupied, 1 and 3 occupied, but not the second slot.
Right.
And this indicates which of the slots have a player that's currently ready.
So then, like, if another player joined, then it knows that it could slot them into spot 2, basically, right?
Exactly. And that's what this function does. Claim first available spot. Just loops over and looks for the first available place to put it.
Yeah, you're using kind of a similar setup with the bool 4 that I know, like, Tobias uses quite a bit. He uses, like, vector 4 for kind of like balancing lookups where, like, if there's, like, 2 players in the game, then it can kind of like do a lookup to see like how many enemies it should spawn.
Oh, nice.
Yeah.
Well, yeah. So here we got the first available slot to us, and then I pair up the controller because now I'm confident that at the very least I have the amount of space available for a 5th player is not going to join, right? Do the same mapping I did earlier. And this is what I was talking about. Like now I can just create an entity that's going to be used later that stores the correct controller. So now I have an entity representing a user, because a user can only store which controller and which devices are attached to that user. We want additional information, so I'm using an entity to kind of represent additional user information. So that's what we have here. I created something that has an input tag, input puppet tag. I call them puppets, these little fake inputs. And there's a kind of reason that you want a separation from your input controller and your actual like in-game representation of the player. Because if the player dies, I still want the puppet to be available so you can like rejoin the game or stuff like that. You can still ask input events even though the player died. So I can't attach it to the player directly. I have to attach this little puppet. So that's what I do. I have a puppet that represented. I also gave it a name. And it also knows about the device, and it knows about the controller. And
So
it knows what...
Just to clarify, that basically always exists, and you're just like always kind of sending input to that, so it doesn't matter that the actual player may be respawning or something like that.
Exactly. Yeah. And you can actually put this controller reference on the player itself, and that's what I do in this here too. But the thing is, then your player dies, and maybe that you want to respawn it. Then you still have the original controller reference, so that you can still re-put it on, right? And then last thing I need to have available to me is both the slot index and user index. And there's a difference between the user index and the slot index. The slot index, obviously, if player 1 joins 2, 3, and you have that hole in the middle that I was talking about earlier, then you have slot 1 and 3. But the user index would be user 1 and 2. And that's also the amount of players you would have, right? You would have player 1 and 2. You would have the amount of players equal to the amount of indices, input users. So that's why I need both of these, because if you look at the main menu, and I can quickly show that, I always want this player to be the red player, and I always want this player to be the black player, I guess, dark color, and then the cyan one is here. And if, say, this controller here drops out, then this player, I don't want, if I only had user index to work based off of, then right now, when I go to spawn my players, he would get assigned the black one. But that's not obviously what I want. I still want him to spawn under the user 2 and the player 2, but as slot free here, right? So that's why I need to store both. It's basically customization options that the slot index is usable for. So, okay, I now have a puppet. Obviously, at this point, I haven't set anything up so that I can actually, ready the player or not, and the player can drop out. Haven't set up anything of that kind. So that's what we're doing here. We're asking, hey, have you currently put in any player? And yeah, this just matches the player, right? And also this input puppet tag, because there's two parts of this. A puppet should both have an initialization state where I register any events, and it should also have the main update where just every frame update and do checking. So this enableable component is what I'm using here to say, hey, if this is true, which it is by default, then you can do your initialization. And then once the initialization is done, then when this to false, it doesn't need any initialization anymore. Yeah, so looping over every player, setting some information up about that player, like for instance, the text below should now say not ready. And as soon as a player joins, obviously I also want all of this to happen. And like this texture should be reassigned. All of the textures in here should be set up. Mm-hmm. The text here should be set up. And this one should be updated. Like if I add a third player, I obviously want this to now say free.
Right.
So that's part of the initialization for each player. And this is also where I can do this little lookup saying, hey, could I please get all the textures, the texture scheme for this specific device that I'm currently looking at? So I'm setting up, I'm in the menu, press play. I just pressed a button on my keyboard. At that moment, I want to figure out what device was pressed and then look up the texture collection for that. So that's what I have here. I have all the textures related to that player. Then I can loop over every action on that player. And I'm going to show later why that's the case. I'm doing that. But the important bit is this clone tree. So that adds one of these segments here. Mm-hmm. And then I assign the correct texture and the correct text name for that, mm-hmm. which I can ask the action about.
Yep.
And then I can get the texture from the texture lookup, get from action and device. People can obviously try and read this part if that's interesting, but I won't go into detail right now. Basically, there is just a mapping between the texture and what button is actually pressed, and that's what this does. And if that button, this action that you put in here, happens to be a composite button, so built up of 4 keys, then mm-hmm. it will also manage building the correct texture for that. Based on this device. So, good.
Yeah.
We've done that. And this is just assigning the ready button so that this button also gets assigned. And I can just specifically call out here, player controller game menu ready button. And so let me go back to why I can loop over every action. When I just take the player controller, the one that we had as a reference earlier, and put on the puppet, then for each loop will naturally give back every action as part of that input controller. So every action that lives on this asset here. every one of these. But it will also give me the game menu here. Enter game, ready, cancel. And the reason I have 2 is that as soon as I enter the game, I don't want people to accidentally start readying up because that's no longer available. So I'm going to disable the game menu.
Clicking
but I don't want
button.
to, in that menu, start showing the game menu because that also, doesn't make sense. Like all the button key maps for the menu. So that's what I'm skipping over here. Player controller, game menu. Check if the action map of the action you're currently looking at is the game menu of the controller. So
makes sense.
That way we can. And that's pretty much it. We've updated the waiting text, and we've said yes. We now have initialized that puppet because we have. And what do we still need to do every frame? Well, we still every frame need to know. And let's go into the game again. Whether someone pressed, not the start action here, which I just did, but we need to know if they pressed space in this case.
The ready button.
Yeah, and we also need to know if they pressed the start game button, and we also need to know if they pressed the exit button. So those 3 events, right? Also, I have a cat that is now laying on my keyboard. Oh my god, I can't exit the game if... There we go.
Good kitty.
Yeah. And now she's licking my finger. So this is the same loop as earlier. The only difference obviously being that we are also allowing... We're not actually checking if that input puppet tag is enabled or not. So okay, if you press the game ready button, this triggered only happens the first frame that is true. Then toggle the menu state of the player being ready, and I can get the available slot because I stored that, as we saw earlier, in the slot in user index. Then change the text between being ready or not based on what you just assigned, and update the waiting text. Same for enter game menu. I check if we have enough players. If not, then just don't do anything. Otherwise, keep going. And if it is the case that we have enough players ready, then don't display the enter game menu anymore because we're done displaying that, and then just call out the event is in game. If you press exit, then we need to do all of this, which I guess I can go into as well. It's simply just make sure to destroy the puppet entity because we don't need the puppet anymore if they exit. Resets the text. Make sure to not have any of the input buttons anymore, the ones that display here. And resets all of the slot player readiness and unpairs the device and removes the user, and then starts listening for an additional controller and updates the amount of players ready. Fairly simple code.
Yeah.
Then, all players are ready. All, enough of the total required players have joined, and all is set. We're in game. What happens then, other than the display going away? Well, we need. Let's quickly look in the game. Start. Boom. Boom. We need something new to happen. We need the original cameras to go away, to be disabled. We need the entities to spawn, obviously. We need those entities that spawned to contain the correct player controller. They should also assign which camera they belong to so that the camera starts working. Obviously, the orbiting camera also needs to point to the player. And we need to assign the cameras that we did activate and disable the game menu action. So that needs to happen as soon as we press play. So this is all I needed for disabling all the existing cameras, like the overview camera along with all of the UI cameras. Just have a tag on those cameras and then delete them. And there's already a way of getting all the cameras. And then I get some of this data. People are allowed to ask. I won't go into detail. Now, then we have to loop over every single one of those puppets. So this loops over the puppets. And then we just do, and remember this is happening in on start running. So this only gets called once when the first time that is in game is created. So is in game, that entity is there for the whole game session. If you were to destroy that game, then you should probably have an on stop running that makes sure to stop the game, right? Then okay, we loop over every puppet that we want to spawn. So if we have 2 players that are ready to join, even if they have slot index 1 and 3, then that's what we get. Then we disable their game menu so they don't start exiting out of the game and disconnecting and everything. We make sure that we get the camera, the correct one, and activate it based on the user's index. So again, this is going to be 1 and 2, even though you have a player at slot 1 and 3, because that's how user indexes work. They get automatically remapped based on whether or not there's a user. And then I have players, the amount of players ready. This is just a singleton that I can get based on the menu state. See, okay, if it's a 2-player game, then for camera number 1, well, at index 0, right? Then you should set it to this full region here. So this just, x0, so it starts there, and then it's half of the screen, so it's
half in the Y, yeah.
Yeah. Half of the Y, full width, and put it at one location, and this should be put at the other location, at the other Y location, 0 and half. Right, so these will in total fill out the whole screen.
So
and in this case,
basically by default, you have it as a 4 screen, but if there's only 2 players, then you just stretch them across the top and bottom, right?
Exactly. And I could also have a case 1 if I wanted to allow for 1 player game.
Yeah. And then so that would also be where you would set if you wanted to center that bottom camera, right? In the case 3, I mean.
Exactly. Case 3 here, then I would say when player index equals 2, assign the cam for player rect to the right value, right? Yes, and obviously, if you were to do that, then make sure that you have some UI that you can enable that has text, has something to display on both sides. Otherwise, you're gonna get what was already in the camera buffer at that time.
Right. Yeah.
Put
some little black bars there.
You can of course also have just a dummy camera that shows some black text that displays into the voice and has a low priority. Then it will be drawn in the background. Also, I got my cat.
Yeah, saying, is your cat trying to type some comments there or something?
No, that was me.
Oh.
No, obviously not. Yeah, then obviously I got the singleton representing the objects to spawn every time a player spawns. So then we can loop over that. So this is just a buffer I got here. Get the singleton buffer of spawn on player spawn, and then turn it into an entity array. So I can loop over that. And then I obviously have to instantiate the given object that I want to spawn. So I will, in the beginning, spawn the character. Yeah. I think, isn't that the case? Yes, otherwise the other thing won't work. Yeah, the character spawned before the orbit camera. I do have that dependency because we spawn one of the entities, and then we check if that entity that spawned is a third-person character data. If that's the case, then I should make sure to that like player 0 obviously should spawn at a different location than player 1, so that they don't overlap physically. Otherwise, they start whacking out physics-wise.
Right.
So that's what I'm doing here. Then I'm also making sure that when the animator gets spawned, I mentioned this in the last episode, how you set up so that when a player spawns, it gets it also spawns when a player entity spawns, then it also spawns a game object representing it. The thing I'm doing here is simply make sure that when that spawns, it spawns with the correct color. And that's why I have put in the slot index here. So basically give me the look of being in slot number 2 or slot number 0. And then the last important bit is that when I spawn a player, I've already made sure that that player on it has a controller reference. You just need to make sure that it's assigned, and that's what I'm assigning here. So every player still has their own reference to a controller reference, but you also have the puppet in case you ever kill the player and need to be able to retrieve that. Then now we've spawned the character, and therefore this is valid. Then we spawn the next one, which is the orbit camera, and make sure that the orbit camera gets the correct user index so that it's matched to the correct managed camera. And then we also make sure that the character knows about it. So the orbit camera starts moving around the correct character. That's what this does. That's why we needed the reference to the camera data to begin with. So this basically just makes sure that the character gets assigned the camera that we just spawned. And then we do that for every player and loop over again. And that's pretty much everything about joining the game. Obviously, there are some extra stuff in here, like is in-game. If you look for it, there are some other usages. Where is it also used? Well, it's used in the third-person player input system, because we only want player input to start working when the game is running.
Right.
So I just wait for it here. And that's also the first time that I lock the mouse, because I do want in-game to use the mouse. And then it's just like the reason that the players move around is because they are, like last episode, they are driven by third-person player inputs. And I can get the controller reference for the given player and just start reading some values of that player. And this is the entire thing that drives the players moving around with their respective controllers. And that's it. Everything else has to do with how the character controller works. But I think if we want to go into detail on how the character controller works, then we should have a specific episode on that.
Yeah. No,
I think it's... Yeah.
I was just going to say, I mean, it always is amazing when you're dealing with multiplayer, especially local multiplayer. Like, there's just so many little things that you need to consider to make sure that, everything lines up for each player and things are all kind of like separated, even though they're all still running on the same machine. So yeah, there's just a lot of small little details that you need to work out. So it's always good to just kind of, consider those different things.
Yeah. I mean, and for me, the simplest way to think about it is just to kind of guard clause things with this. Because then you can make sure that one part of it is set up correctly, and then you can set up the next part correctly, and then kind of segment it. Because you always are going to kind of have your join screen. And so that input starting screen I have, there's no reason that couldn't be exchanged for like a netcoded multiplayer also, having that join in the session. And then you have
right.
2 of those. But if you notice, then the inter-game menu one can still work, right? There's nothing that really... I mean, there's a few things that might prevent it a little, but it won't take you a massive refactor to take this join game session system into one that supports a netcoded multiplayer version.
Yeah.
Yeah.